Precise settlement monitoring was needed for a building constructed on variable and compressible soil. However, the site was located in an area of restricted access. Applications for site inspections to obtain in situ settlement measurements were made and denied. So, how could the stakeholders get around this issue? Stay tuned to find out. This is IAM News, bringing you the very latest in infrastructure asset management. I'm Iphigenia, welcome. Today's top story is the use of corner reflectors in remote sensing, particularly their benefits in monitoring assets in remote locations. Corner reflectors are specific structures used in remote sensing and radar applications to enhance signal reflections. They work on the basis of retroreflection, which redirects radar waves back to their source. The key to a corner reflector's effectiveness is its unique geometry. It consists of 3 flat surfaces to form a corner at a 90-degree angle. When radar waves approach the corner reflector, they strike one of the flat surfaces. The angle at which the radar waves strike the flat surface is the same as the angle at which they bounce off. In simple terms, a corner reflector is like a ping pong for radar waves. When radar waves hit, they bounce off the surface in such a way that they all come together and head straight back to the radar equipment. Corner reflectors are useful in situations where radar reflections from the existing terrain cannot be guaranteed, such as in areas with dense vegetation or where there is continuous construction activity and earthworks. They are also useful when displacement data from InSAR is required for a specific point as opposed to a pixel that may be several meters wide. A good example is the building on a site with restricted access I referred to at the beginning. Settlement data was needed for specific locations, and this was provided by InSAR data following the installation of corner reflectors. While it is usually possible to obtain displacement data retrospectively from InSAR undertaken on archived images, one disadvantage of corner reflectors is that they provide improved radar reflections only once they have been installed. They can also be quite large, typically about 1 meter across, so they can't be installed in all locations. The size depends on the SAR satellite being used and the characteristics of the surrounding terrain. It's also important that they're installed at the correct orientation so that they're pointing directly at the satellite each time it passes over. So take a moment to reflect on the pros and cons of corner reflectors. You've been watching IAM News. Join us next time.